Aloha, Rich Halverson here, and this is ITS148, and we're gonna today I'm gonna do programming project 17.1, which is a heap sort problem. So let me share my screen. I'm gonna do this one right here, 17.1. So if we look at that, it's like this. A heap is presented in the text. The heap that we show in the text is called a max heap, and the reason it's called a max heap is because it's a heap that's designed where a node is always bigger than either of its children. Okay, so it's a binary tree. So when so as you go down the tree, the nodes get smaller, but the rule is that each node is bigger than either of its children, and so you can sort that way. And so what this project has us do is to revise the heap sort program so it uses a min heap instead of a max heap. Okay, so and then we're supposed to write a test program. Okay, so and when this thing runs, it like for example, you enter in these numbers here, and it sorts them. Okay, so so this doesn't really demonstrate that it's a difference between a max heap or a min heap, but this is what the output should look like when this is the input. All right, so the way I'm going to do that, okay, first of all, I'm going to just copy this and set it aside to make sure all right, so that way I can refer back to it and I can go elsewhere in the textbook. So I'm going to go back to the table of contents, and I'm going to find this so-called max heap that's described in the book as it says. And so sorting, here's heap sort. Here's heap class. Okay, so let's just take a peek at sorting, at storing a heap. So we can remind ourselves what a heap is. And a heap is, it's a tree, and a node is always bigger than its children. So as you go down the line here, you see that the nodes get smaller and smaller, and each node is smaller than its parent. So that's another way of describing it. And so, and the way these are, it's a full tree. There's no like, which makes it nicely representable as a list, and where this is the first one, second one, third one, fourth one, fifth one, sixth one, seventh one, 8, 9, 10, 11, 12, 13, 14. And so that they're just stored like this, and it's easy to write a little program to find like a parent. It's like it's easy to come up with expressions where you can compute what the parent is, and your children, the index of them. Okay, so anyway, and this talks about that. So I just wanted to review this. If we go back now and let's look at the heap class, because that's got all the code in it. So the heap class looks like this. So here's the heap class here. So see, they kind of give it to us, and let me just sneak and see what the answer is. So you can create this heap object, and you can add to it, and you can remove remove a node, and it's always going to be like the top node, and then it has to reshuffle. And you can get the size of the heap, which is how many nodes there are in it, whether or not it's empty. You can peek at the top element, and you can just display out a list of the heap. And so there you're just showing the order of you know, the list that stores the heap, basically. Okay, so I'll tell you what, I'm going to copy this, because this is going to no doubt be in our solution. Copy, and let's go over here to my paste. Okay, that's a good start. And then let's move on to the next page here. And we have sorting using the heap class. So here we have, this uses the heap class that we just copied over. So I'll tell you what, I'm going to copy, well, I'll copy the whole thing. Oh no, I want the answer first. Okay, there. Copy the whole thing. Copy. And I'm going to go back over here and go down to the bottom. And I'm going to paste it here. Control V. And so now now I don't have to import anything. I don't have to import the class. This would be the file, and this would be the class. I don't need to do that because it's already in the same file here. So I can remove this. Okay, I want to remove that top line. I actually didn't have to copy it over, but I did anyway. And then see, I think that's it. Yeah, I think that's it. Okay, so now, oh, and then I got to make it so it, well, first of all, I'm going to see if this runs. I'm just going to see if this runs. Save this, and py test.py, and okay, it does run. It runs. It prints out this list here, and is it already sorted? Oh, no, it's not sorted. The -4 is over here. It should, -4 belongs right here. Okay, so this works, but we want to make it so it. Oops, where's my snipping? Oh, we want to make it so you can enter numbers, and then it displays out. So instead of, so we want to replace this with something that reads in list. Okay, so I'm going to just do, I'm going to comment this, because I never like throwing anything away. You should see my office, it's a big mess. So I'm going to input some numbers. Let me put this up here. This is going to be some string of numbers comes in, nums, num string equals input enter numbers. Okay, and then I want to convert that into the list, and the list is going to be, let's see, first let me convert them into items. Num. I'm just going to do num items. I just can't think of good variable names off the top off the top of my head. So I'm going to call it that. And so I want to split num string split based on blanks. I'm going to have them be separated by blanks. Okay, that works that. And then I got to convert this into the list. I got to have this list here. And that's going to be, it's going to be a list. And inside the list, I want to convert these numbers. So I'm going to say float n. I want to make it floating point for n's in num items. Okay, so this is going to be one string that's entered in, and then I want to split out the numbers because it's a string of numbers separated by spaces, and I want to separate and I want to convert that into an array of numbers. So that's what that is, but they're still strings. So then I want to convert them one at a time. So this does one at a time, and for each of those one at a times, I want to convert it to a floating point number, and that's the list element that I want it to be positioned into the list. All right, so and then we sort it, and in fact, if you want, I can print this out. I think. Does this work? I think it does. Entered list. So let's see that this. Okay, so now I've successfully replaced. See, here it's just defined, and this actually allows me to read them in, and it ends up being there, and then it continues here. All right, so let's see what this does. Okay, now it's asking for a list. I'm gonna, oh, I can't. 4.5, 5.4, 9.3, 3.4, 1.5, 7.7, 5.6. Okay, how's that? How do I copy this? Copy. Oh, just enter. All right. Anyway, and it sorted it out fine, and it displayed out the entered list. That's what I wanted it to do. Okay, so I'm gonna just I'm gonna put a comment here of that, just in case I want to use that again. All right, so so I got this thing to work using heap sort as is, and so now what they want us to do is to convert from a max heap to a min heap. So so I'm going to dig around in here and see where I can find just where the heap is created, and I'm going to display out that list, and I'm going to use this heap get list method to do that. Okay, so where do we create the heap? Okay, here's the heap sort program, and here we create an empty heap, and then we loop around and we add each one of these, each one of the items, or the numbers now, if the floating point numbers from list, we add those to the heap one by one, and when we add them to the heap, it heapifies, and so each time you add it in there, and it reheaps the heap, so the whole thing's a heap. And so at this point right here, excuse me, got part of my lunch in my mouth still. Display heap. Okay, so I'm just going to do that, and I'm going to do print heap heap get list get lst like that. Yeah. Okay, I want to display out this. All right, let's see what it looks like now. Up, see? Enter the numbers. Okay, copy these. Copy. Okay, here it displays out the heap, and you see this is the top node. These are the next two nodes, which are both smaller than the 9.3, and then this is a child of 4.5. It's smaller. This is also a child of 4.5. It's smaller. This is a child of 7.7, and this is a child of 7.7. Okay, so that looks like it's a heap, and it's a max heap. Because these are higher, these are bigger than their children. So we want to figure out, we want to modify this program now to make it so we're using a min-heap, and it still functions the same. It still displays out, it still is able to do a successful sort. Okay, so here's how I'm going to do this. And it didn't take me very long to do this because I'm just looking for clues of when we're dealing and inserting, when we're moving around nodes, items, or reconnecting them up, where we're testing if one is bigger than the other. And I'm going to just change it to make it if it's smaller than the other. Okay. And so if we kind of start at the top here, and we go down the line, and it says, okay, here it says, okay, here we're adding into the heap. And what we do is we loop through the items, or I think that we stick it on at the back, and then we reheap it. And this loop here does the reheaping, and here we do a swap if the current item is greater than its parent. Well, let's change it to if it's less than its parent. Okay, sure. So I'm going to change this to less than, and I'm going to change this to less than. Okay, and then I'm going to put a little marker deal there so I remember what I did. Okay, what else we got here? Remove it. Oh, when we remove it, we got to reheap again. This is index. This is finding the children. It's finding the children. If the left child index is no, that's still finding the children. This is still figuring out the, oh, swap if the current node is less than the maximum. Oh. Well, you know, I think we're dealing with minimums and not maximums. So I think this really should be, and I'm gonna copy paste this one because I want to swap the current node if greater than the minimum. I'm just guessing here, but this doesn't matter too much because really what matters is we get these. Okay, so this is a something and a something, and so we're gonna do changes to greater than. Okay, what else? Oh, I gotta put a little marker there. Okay, get size is empty, peak list. Oh, okay. It turns out when you create this list from the sorted list from the heap, you remove the top item and then you reheap it. So and by removing the top item, you're always removing the biggest node in the whole heap. And so when you're building this list, you want the list to be, you know, in ascending order. So you're building it from the back to the front. Okay, so when it's a max, when you're using a max heap, and you generate at the very end, you create your list from the heap. You know, you just loop and you pop off the top. You keep on popping off the top, and this remove returns the top one and then reheaps it. You end up building the list from the very last element up to the first element. See, so this is the first one is going to be the length of the list minus 1. So if there's 10 elements, it's going to be 9 minus 0. So the first element you're storing in there is the ninth element. Say there's a total of 10, and then the next one is the 8th and the 7th and the 6th and the 5th. So so that's an artifact of a maxi heap, of a max heap. Now we don't need to do it that way. We can just do it because we're pulling off the minimum. Where each time we're pulling one off, it's the biggest, it's the smallest one of the whole heap, and so that's how we can build our list in ascending order. So just to remember, I'm going to comment this out, and I'm going to replace it with this, and I'm just going to say like divide like that. All right. Okay, I have one more thing that I thought I did, but didn't do. But anyway, okay, so anyway, I'm going to run this. I think, I don't think I got them all, but let me just run this and see what this looks like. So let's try to run this and enter some numbers. And I think I'm going to try to enter the same numbers. Copy, paste. Oh, it's not sorted. Okay, see? So, okay, so the heap is definitely, this is smaller than these two. This one is smaller than these two. And this one is smaller than these. Okay, so it definitely is now makes a min heap. Wait a minute. Well, anyway, it's not this. This is not correct because this number here should be over here. Okay, so we aren't there yet. What did I miss? I got this one. I think I do need the indexes. Oh, here. This one. This is a list max index with a right child index. Okay, well anyway, yeah, that's wrong. So I got to change this to well, I'm not sure what the comment would be, but I'm just going to change this to I'll put this here, and I'm going to change this to greater than. All right, so I changed 3 greater thans. I changed this one, and I changed this from a greater than to a less than. I changed this from a less than to a greater than, and this one from a less than to a greater than. And so let's save it now and see what it looks like now. Enter numbers, copy, paste. And it looks like it worked. Okay, let's see. Let's do one more test here. Let me go here and I do it. If you you can search and find websites that generate random numbers. So there's one here, this integer, integer generator at random.org. All right, so I'm going to generate one set with 20 random integers. And integers should be between 1 and 50. And I'm going to number this. No, I don't want, oh, it doesn't matter. I'm just going to do one set. I'm not going to use, I don't want anything to separate. I'm just a space. So I don't want them sorted. I'm going to sort it. Okay, here we go. Here's a nice random set of integers. Copy this. And let's go try this one now. Paste. And here are the numbers. This is what the list looks like. This is what the heap looks like. Min-heap. And when it's sorted, they display out in nicely sorted order. Okay, well, so anyway, I've given you enough to be able to figure out how to do the problem now. You need to figure out what to paste in and everything. But you should be able to do the, take the max-heap class and convert it into, so it uses a min-heap. And then write a sort program from that. Thanks for watching.